our next speaker is Armin, and he's going to discuss data analysis with data.table and dplyr, which should be interesting. And thank you very much.
Yeah, thanks. Can you guys hear me okay?
Yep.
Okay, good. So I apologize. The slides themselves are sort of, they're just in time. But I think the content is good. So I wanted to talk about data tables. I think you guys had a presentation on dplyr, I think maybe a couple months ago, right? I'm a heavy user of data tables, so I thought it'd be a good way to sort of talk about data table a little bit and then contrast the two in terms of speed and efficiency, things like that. I think coming from a business background, so undergrad business, master's business, I've taken your typical statistics classes, a little bit of data mining. It was only a couple of years ago when I actually discovered this whole beautiful world of R, right? And the fact that we can use open source and be 20 times more efficient than your typical corporate world, right? So having said that, I think everybody in this room is like at least four times smarter than me. So if you see anything that you want to chime in, please do so. So just again, bit of background. I was hired for MillerCoors a couple of years ago to start up a pricing team. And as part of that, I had to start up an analytics portion. We kind of managed the tactical piece of pricing as well as strategy. But I inherited a team, right? Inherited a team that worked for this corporation that they used all these tools, crazy tools like Excel and Minitab. And of course, you can't blame them, right? I was good at Excel and Access and all that stuff, but that's sort of where my knowledge stopped. And this is in 2002, summer of 2002. And pricing is a very analytical function. And most people don't realize that you have to do a lot of statistics, right? Whether it's just simple exploratory stuff around how your business is doing from a pricing standpoint to simple statistics, right? Your multilinear regression, figuring out what your price elasticities are, what your cross elasticities are. If you guys are not familiar, I think most of your price elasticity, how sensitive is your product to changes in price, right? And so I had my team doing regressions, and I would be interested in the elasticity of 20 products. So these four guys would literally run 20 different regressions in Excel, and if I asked for 50 products, it would be like a half-day exercise, right? And so I thought to myself, there has to be a better way. There has to be a better way, right? And that's when I discovered some books, and I started learning, and next, one thing leads to another, and so I learned R to the extent that I can, and to the extent my background allows it to do. But I soon became much better at that stuff than my own team, which is a little bit sad, right? Because I'm by no means that smart. And so I've been using that ever since. So in the interest of getting to know each other a little bit, here's something about me. So one of the things that I've noticed on the schedule is my last name, which is Kakas, was spelled Karkas. Now Kakas means rooster in Hungarian. This is a very eloquent name. It means rooster. When I first came to the States, I told everyone my last name is Cock, and everybody was laughing at me. But it means rooster. And so I think in the invite tonight, my last name was spelled as Carcass, which is of course a dead animal. It's slightly different spelling with same pronunciation. So I wanted to show you guys, this is what happens when I go to Starbucks. So I go to Starbucks and I spell my name out clearly, A-R-M-I-N, and I would get Armand. I think the other week I got Harmon. This was about a month ago. I got Carmen. I don't think I look like a Carmen, and then this is a Marvin. This was like a week ago. So I keep taking pictures of what they give me at Starbucks. This one time I actually got a cup that says Ahmed. How do you go from A-R-M-I-N to Ahmed? I have no idea. I think sometimes they just really want to mess with you. So a bit about me. I was born in Serbia, which is that communist star on the top, actually on the bottom, and I moved to Hungary in '91. So I'm both Serbian and Hungarian. English is like my fourth language. So if I say something stupid or inappropriate, just I can blame on the fact that I'm not American. The word on the top is the longest word in Hungarian. Can anybody guess what that means? No, it's legesleg messzentségtelenítetlen embereknek. It means people that cannot be ordained as saints. There's a word for it in my language. So you can take that away. That's me. I look like a sumo wrestler when I was a kid, very stylish, riding a pony and breaking the pony's neck. That's my favorite place in the US. This picture points to the Big Sur area. So it's beautiful. I brought my parents over and they loved it. A couple years ago, I experienced Disney World for the first time in my life. So that's my wife and I went to Disney World. So that was good. I was like a little kid, and that's our wedding in Nashville. She's the pretty one in the family. A couple years ago, I became very passionate about data. Right, my eyes sort of opened, and I realized there's a lot more to data analysis and data science and statistics, right, than just your rudimentary stuff that exists in corporate America. And this is not to bash corporate America, right? But the reality is, in most companies, people just don't know what they don't know, right? And so we rely on very rudimentary methods. Most of the decision making is based on folklore or gut feel, right? And whoever is the loudest is the right one, right? So I love this stuff, and I do a lot of studying in my free time, right? I get up at 5 and I study. We also love reality TV, so I watch The Bachelor and Real Housewives. Any Bachelor fans? Among you don't have to be ashamed. You do agree that Chris picked the wrong one, right? Yes. Okay, good. And I love to do yoga. All right, so off to the actual topic. So dplyr, you guys had the training, right? It's sort of the next iteration of plyr. It's very effective. I use it every day. For those of you who haven't used it, it's much faster than your data frame, right? So it's a lot faster to do certain things, especially your typical grouping stuff, like your typical split, apply, and then combine some elements and output it, right? It's a lot faster than your base R function. One of the cool features is this table class, right? It allows you to display data just a lot more effectively than just saying head data frame or outputting the data frame. The reason I like it, and if you guys want to learn more about it, I included some resource elements at the end of this presentation that you can just kind of click on and literally print out some tutorials. One of the reasons I like it is coming from a non-computer science background, right? It's a lot more intuitive, right? It kind of follows your natural language structure. I want to do this, then I want to do this, then I want to filter, then I want to group, then I want to apply some functionality. So to me, it makes sense, right? Just being used to learning foreign languages, it's a lot more natural. Now, data table on the other hand, right? And tell me if you guys can't read this. The main author is a computer scientist by the name of Matt Dowley. And it's interesting when you look at some message boards about R, and people debate dplyr versus data table in terms of speed and efficiency and functionality. You sometimes see Hadley Wickham, who's the creator of dplyr, and Matt Dowley sort of go back and forth, right? And it's sort of a passive aggressive, who's got bigger muscles kind of thing. So it's sort of entertaining. But it's like a data frame, right? But on horse steroids. So, right, like this guy, right? It's like data frame, but on horse steroids. It's better, it's stronger, it's faster. All the functions that work on a data frame do work on a data table, right? And it's very simple to just convert a data frame into a data table. Or you can just create a data table, which we will do in the next step. Reading files is incredibly efficient and incredibly fast. And that's, also in the pricing team, I now lead a team called Advanced Price Analytics, which there's nothing advanced about us yet, but we work with okay sized data. So 10 million rows, 20 million, 30 million, 50 million, right? Nothing too crazy, but still sizable. So for that, we need to be able to read stuff, text files, CSV, whatever. And it's data table is just a lot faster. So if you guys work with large amounts of data, right? So at least a gigabyte or at least a million rows, I definitely recommend using data table. So let's create a quick data table, right? It's you can create a data frame, and everybody knows sort of how to do that, right? I try to mimic a data that we sort of use in our company, right? Pricing data. So you kind of see the price, you see the retailer, and you see a product code there. So that's a data frame, right? We created a data frame very simply. So to create the data table, you would do it the same way, except data frame. Syntax you call data table, right? Same exact thing, very simple. And so looks the same way, acts the same way, feels the same way, right? Or you can just convert it, right? So the previous data frame that we created, you can just say as data table or data table, df was the name of our table, and it'll convert it very easily, right? And you can see the statement, they're essentially the same thing from a feel and data structure standpoint, right? Now, it also enables some very, very fast reading of data. We talked about that. So here, I just simulated a data, and we could have done this as a live demo. But I'm creating a data frame, right, a million rows, 2 columns, and I'm outputting it as a temp file, writing in the table, and then I'm reading it in. I'm using the function called Fred, which is part of data table, right? So Fred, you input the file name, it'll intuitively know or guess what type of data it is, right? And it'll sort of guess what the column types are, and reads it in. So using the Fred function, it actually took me about 9 seconds versus, or it took me about 0.3 seconds versus using the regular read table function, it took me 9.3 seconds. So on a relative basis, again, a lot faster, right? 20, 30 times faster. And these advantages, guys, become very apparent when you use bigger data, right? When you use 50 million rows, 30 columns, try to do that with a read CS or read table, it'll take you, 30 minutes, 40 minutes, right? With Fred, it'll take you maybe a minute, maybe even less than a minute. So again, with OK size data, I think it's very, very effective. So how do you guys think about data table functions? For some of you, I think, know data tables. For those of you that don't, it's also very intuitive, right? The syntax, you have to think about it a little bit sometimes. It's not as natural as dplyr, is not as R-ish as some of the other base functions. But here's the way you think about it when you do manipulations and data munging, right? The essential syntax is you take the data table, right, DT, you take the data table, you subset the rows using I, and then you calculate J, which is a calculated column, and you group by. And we'll see some examples, right? So you take the data table, you subset the rows using I, calculate J, group by. And you will have a data table cheat sheet that we'll give to you that you can download that it kind of features all that. Once you create your data tables, let's suppose you created 5 of them, you can see what all you have in the memory. Very simple function, tables, and it'll display what you have in the memory. Now, how do you subset rows, right? So we've created a data table that has price, retailer, and has product code. So first example there, right? We want to see the second row. All we do is we say DT. We subset rows using I. So we subset the row using 2, which is the second row, right? And it's going to return as the second row, right? Very, very simple. Now, what happens if we only want stuff that belongs to the retailers, Amazon or Lowe's, right? And I want the prices to be between $50 and $100, right? Let me enlarge this syntax for you guys a little bit. Very similar, right? So pay attention to the stuff that's to the right of this head command. Right? You take the data table, you subset the rows saying price less than or equal to 100 and price greater or equal than 50. And retailer is in this list. Okay? And that's it. And it returns it. Very simple. Again, the syntax is not as natural as you would find for a data frame. But I think once you get used to it and once you keep thinking about this statement, it gets pretty intuitive. Now, manipulating columns, it's a little bit different, right? It's a little bit different than data frames. I think some of you may use a dollar sign. Some of you may use a transform function, right? This one used an interesting little thing, right? You can actually specify multiple columns, multiple new columns, right? Where here we just want to see the minimum and the maximum price across the entire range, right? So we just say minimum price equals minimum price. The key thing is that area, right? You specify a dot, and in parentheses, you specify all the different new columns that you want to calculate, okay? Now, if you actually want to do calculations that are non-aggregated, right? Let's suppose we want to add a new column for margin, which is critical for retailers, right? And here we're sort of inferring or calculating a hypothetical margin. Typically, you would obviously calculate a price minus cost. But the syntax is, again, a little bit weird. But what you'd say is you specify what the new column is. We call it margin. Then column equals sign. And then you specify whatever that formula is, right? It could be anything. And that's it. So whatever your new column is, column equals sign, and then it calculates it. Now, yeah.
So I'm not clear what the dot does. So I've used data table, but I've never seen that before.
Yeah.
Does that mean aggregated the whole data?
This one just aggregates it. So it doesn't actually input a new column for the existing data. This one just creates aggregated functions. or aggregated output.
Okay, so it's like doing by one or something.
Say it again?
It's like doing by one or something like that.
Yes, you can actually specify a by, but we didn't in this case. Yep. Yep. Now, if you want to add 2 more columns, I think there's a couple of ways to do it, right? I'm using, and you will see it on the cheat sheet that you can download. I like to use lists, right? So I guess each column is treated as its own list. So therefore, you can put new columns in there and specify a list, right? So here we're saying we want to take 2 new columns. We'll call them cost and month, and we'll put a list, right? So this is non-aggregated, right? You put 2 new columns. You say, hey, I want my cost to be price minus margin. Obviously, in reality, right, it's the other way around. You have a cost figure, you figure out the margin. We're going a roundabout way. But we say list, and we list out the formulas sequentially that belong to these new columns that we specified, right? And that's it. And we just assume that the month is going to be March. Now, we can also group with aggregation, right? And it's exactly what we just did earlier, except now we're specifying a by function, right? So let's suppose we want to see the average price and cost by retailer, right? All we're doing is we specify what the new column is going to be, right? That's going to be the sort of aggregated, and we specify what the formula is. And we specify by, right? So we take the data table, we subset the rows using I. In this case, there's no subset. Then we calculate J, right? Here's J. We calculate what the column is, and we group by. And in this case, we group by retailer. And output is a very simple aggregated table. Now, obviously, if we want to see it for Amazon and Best Buy, which is 2 retailers, we can just sort of filter out the rows, and it would give you a limited input, right? Now, with that aggregation, it's the same example that we saw earlier, except now we actually have a by function, right? So you include some new columns called average price and average cost, right? And you simply include the by retailer. Now, we can actually use chaining to calculate other fields. And I'll show you chaining in a little bit, right? Table joins incredibly fast in data table, partly because we can actually cheat a little bit. So let's suppose we have 2 data tables, right? Data table 1, data table 2. I think I'm specifying in data table 2, I'm assigning a quarter to the month, right? Very simple, and I'm trying to merge the 2 together. We're cheating a little bit because we're assigning a set key, which would sort the data table by the particular column, right? So it's just a lot easier to join the 2 together when it's already sorted by the common fields. And then it's your regular merge function, right? dplyr, you use a SQL type syntax, right? Data table, as you will see, is actually faster. So we'll do a demo, guys. And before I begin the demo, let me start the R code because it may take a while to finish. And I know it looks a little bit ugly here, but I'll make the code available, and you guys can just download it and see it. So we're going to run all this messy stuff, and I'll explain you what that is. But for now, let's just run it. Okay. So let me explain what we're doing. So I work in the pricing team, and our job is to try to compete with the likes of Amazon, bless you, likes of Amazon, Newegg, Walmart, e-commerce, and I'll be very frank, guys. Brick and mortar retailers traditionally have been very simplistic in their approaches, especially to pricing, right? A lot of manual stuff, a lot of Excel, a lot of emails, a lot of PowerPoints, and a lot of headcount thrown at sort of changing prices. What happens with Amazon, what happens with Walmart, it's algorithmic pricing, right? It's machine learning. It's, I think Amazon is moving towards deep learning, whatever that means, right? But they're crazy. I mean, they're certainly beyond the Excel and the minute tabs, right? And so we're still sort of stuck in the Middle Ages, but we need to get better. So one of the things that we need to do is figure out what is the price elasticity of all of our products that we carry. So of all the products that we have in our company, how sensitive are they to price changes? So we'll pull in some supporting data, right, that we'll sort of munch together and we'll do some analysis, and we'll compare, is dplyr faster or is data table faster? Which one should we actually use? Okay, so this is real data, guys. I couldn't make the data available because probably be put in jail and deported, but at least you'll have the code. So we'll have clearance data, right? It's simply, it's an okay data set, right? 50 million rows roughly. It's clearance. On a daily basis, it tells you which items are in clearance, right? So which items are on deep discount, which items are on promo, right? It's a smaller data set, right? Sales pricing, it gives you day by product code, the pricing history for the entire 3 years, right? So about 1,000 days, call it, 40,000 products, right? Store count, same thing. What is the number of stores for each and every product that we sell each day that sold that product? It's a proxy for distribution, right? What is the level of distribution for our products? Traffic, how many people are visiting our stores and buying our product, right? What is it, or not necessarily buying, but how many people are actually coming through the store, potentially interested in buying? So we munge all this data together, we come up with some analytical data set called reg data, which is significantly less because we exclude some products and we say I'm only interested in the top 80% of the sales because I don't care about the rest. 20% of the sales is probably comprised by 80% of our products. It's a bunch of crap, right? It's products that nobody cares about. I only care about the 80%. But it has about 2.3 million rows, right, and 34 columns. So we'll do some munging, and I'll show you guys the code afterwards. But for now, just know that we've done a bunch of stuff in the background, right? So the first example, the first comparison is we're going to create a new field and select a specific column, right? It's simple stuff, but you're doing it across a large data element. So all we're doing is we're saying, with dplyr at least, right? We're converting the clearance data table. We're converting it into a table data class. Easier to display. Just visually, it's a little bit more appealing. We're creating a new field called clearance flag. It just simply says, hey, just put a 1 under it. It lets us know that once we merge the data, there's going to be a 1. It's going to be a binary indicator whether there was a clearance or not, right? And then we're going to select all the columns from the date field to the SKU field, which is the product name, right? And we're going to select the clearance flag. Now we're doing the same thing with data table. We're saying put a new column, right? Clearance flag, and then the column equal is 1. And then we're using chaining, right? So you can actually use chaining in data tables just like you would use piping in dplyr, right? So similar concept. Using chaining, and we're saying I only want to select these particular columns. Okay, so that's our first example. The second one is we're creating a new field and we're filtering, right? So the new field is weighted price, which is sales divided by unit quantity. We're rounding it to 2 digits, right? So price is sales divided by units. Then we're using piping to say, I only want to look at records where the price is greater than 1, assuming that if the price is less than 1, it's an error. Nothing sells for less than $1 at Best Buy, right? Or at least that's the assumption. Something may, but for the most part, it's an error. We're doing the same thing with data table, guys, right? So similar syntax that you've seen before. We subset the rows, right? Channel ID equals 110, which is simply stores. Weighted price is, again, sales divided by quantity. And then we're using chaining where we're filtering, right? Weighted price is greater than 1. So that's example 2. And keep in mind, this is going across 30, 40, 50 million rows of data, right? Example 3 is joining. So with dplyr, it's kind of what you do with SQL, right? You're doing a left join and you're doing it in these fields, data and SKU ID. Now with data table, we're cheating a little bit, right? We're actually sorting the data automatically by these keys. The cool thing is with data table, I don't know how much you guys can see this, but we can dynamically set the keys, right? I'm specifying this variable. I'm saying key calls equals data and SKU ID. So therefore, I'm referencing this character vector when I set the keys. Okay? I think it's a really cool function, especially if you have more than one column that you want to set the keys in. Then all you're doing is merging, right? So we're cheating a little bit in data table.
I'm sorry.
Yeah.
Can we go back to the keys thing?
Yeah.
I lost it. Must you specify the keys though?
You don't have to. No. The only thing it does is just it speeds up the merging a lot faster, especially if you have two large data sets, right? Setting the keys will sort that particular data on that particular column or columns that you specify.
And can you do that in dplyr as well?
Sure, you can sort the data. Yeah, you can sort the data. It's just I don't think in dplyr there's a particular function that does that in a very systematic way. I think you would have to literally arrange the data, right? But you're right. We're cheating a little bit in the data table case, but we're only cheating because there's a very handy function around it. Okay. Example 4. I know it's messy, guys, so bear with me. And I think the formatting is a little bit off. You can't really see it. So I'll explain you what this does. Right. So what we're doing, and those of you who are statisticians, don't judge me. It's a very simple model. We're essentially just creating a new column. And I'm calling that new column price elasticity. Okay? And really all it is just simply the coefficient when you do sort of a log mixed regression, right? Log of units regressing on the log of price, and then a bunch of dummies, right? Ones and zeros, okay? So we're controlling for things like, here, let's see how much you can see it. We're controlling for things like traffic count, okay? So how many people go into your stores. We're controlling for things like how many stores sold that product, right? So think of it as a time series data, so it varies, right? We're doing this on a daily basis. Was that particular product on promotion or clearance? Okay, because if it was, right, your price is naturally going to be lower, but your sales is also going to be crazy because there's likely going to be some marketing effort around it or some advertising or some display in the store. And there on the right you see we're controlling for things like, is it a weekend or is it a weekday, right? I don't know about you guys, I just don't shop for electronics during the weekday unless I really need something, right? I would typically go on a Saturday or a Sunday. And then we're controlling for a bunch of seasonal variables, again, dummies, month of year, and the particular year. Again, not the best way to do price elasticity estimation, but within the context of brick and mortar corporate America, this is as good as you're going to get, right? But the beautiful thing about this, guys, is, at least for me, right, is it allows you to actually loop over 4,000 products, or however many we have here, 5,000, right? Or 4,000 products, and it just spits out the results. So instead of having to do a for loop, instead of having to do a, I don't know what would be the other way, do by or doing a regression by, right? And then you're trying to apply and see bind the results, right? You're just simply saying, hey, create a new column. We'll call it price elasticity, and do all this crazy regression. When you did the regression, take the coefficient, take the second element of that coefficient, right? The first one is going to be the intercept. Second one is going to be whatever the first independent variable is, and put it out in a nice little tabular form, right? And we could have done this with 10,000 products. We could have done this with 1 million products. It would do it really neatly. dplyr, similar logic, right? You're taking the analytical data set. Here we're grouping by SKU ID first, right? We're doing the same thing here by SKU ID at the end in data table. And we're just saying, hey, summarize this. Give me the price elasticity, which is defined as the regression coefficient, or the second member of the regression coefficient. Oh, and by the way, I want to see the average units that appear on a daily basis. For whatever reason. Maybe I want to evaluate, do larger products have higher price sensitivities? So we've done all this, and I know it's a little bit hard for you guys to conceptually see what's happening. I just didn't want to waste everybody's time. But this is sort of the analytical intent, right? So then we've done a nice little time comparison. And I should have used Python for this one, but I used ggplot. But here's how the results come about, right? So again, okay size data set, right? It's nothing too crazy, 50 million rows. The analytical data set when we did the regression was about 2 million rows. And really, in almost all cases, data table is much faster, right? A lot faster. For the joins, even though we cheated, right, because we kind of sorted the table at first, but it was significantly faster. When we created the fields, it was a lot faster. Same thing when we created the fields and filtered the data, again, 50 million rows or 40 million, it was a lot faster. Now, when we actually did the regressions by group, sort of equivalent, right? I mean, there's really no difference. Really, this is sort of my summary, guys. It's definitely try it at home and read some of the additional links that we put out there. I think dplyr is easier because it aligns more with at least the way I think. So it aligns with sort of the natural flow of how you would think about data analysis. If you're analyzing small to medium-sized data sets to up to 10 million rows, right? It's okay to use dplyr because it's easier. It's a little bit more natural. For larger data sets, I think use data.table. It's faster and I think it's more robust. They offer similar functionality, right? It's very easy to convert. So if you just have data frame, you can just convert it into a data table like we've seen. When we did the regression, it was group level analysis, right? It was sort of very similar because we only had about 4,000 groups. Now, if you just have this massive data set that has 100,000 groups or a million groups, right? And sorry for the little bullet points here. Then use data table because it's a lot more robust, okay? But it's a lot better than your base function. So here's some resources to put down on dplyr. I think a lot of these are excellent. The one that I use on a daily basis, guys, is the dplyr and tidyr cheat sheet. I think it's on the RStudio website. I'm sure many of you have seen that. Same thing with data table. There's one put on by Data Camp, I believe. It's a neat little website that charges money for to do simple tutorials, but their cheat sheet is very good.
They also have I think it's a 4-hour course on dplyr.
They do?
Yep.
Free?
No.
Okay.
Who is it? $95.
$95?
Who makes the course?
Datacamp. Datacamp.com. Yeah. I think you can, honestly, for data tables, you can go to Coursera. There's whatever the course is, like a data munging course. There's a data table lesson and there's a dplyr lesson. For dplyr tutorials, I honestly thought that this guy was very good. And I'm not connected to the internet. But there's a tutorial and there's a link. It's not very interactive. There's a video associated with it, but it's very sequential, and I think it's very easy to learn. And so let's see if our code actually ran at the end. Yes, it did. And if you guys want to get an idea of what the output was from all the mess that we've done, we can actually take a look at it. See how these elasticities look like. Okay, there you go. So keep in mind, we've done all this stuff with 50 million rows and joined and munged and whatever. And here it is, right? Here's our product IDs. Here's what they sell on an average day. And here's our price elasticity, right? For the most part, they're not that elastic. We call it inelastic. There's a crazy one, -4. I think it's directionally okay, right? Don't judge me. It's probably not the best statistical way. So hopefully I helped it a little bit. Presentation was just in time, but if you have any questions, ask me or shoot me an email. So, yeah.
Did you try doing any time where you included the set key in the join? I was just curious.
Did I include a set key?
Well, so include in the thing you time, both the join, the merge, and the set key.
Got it.
Which takes some time.
No, with the data table I treated and I included the set key.
Okay. I was just curious. I think in my experience, it's still faster. But
Yeah. So I think data table, at least with the sizes that we work with, it's a lot faster. Now we've started to move towards Hadoop adoption, but it's still very much in the elementary phase. For the most part, we're still just using Hadoop as a data storage mechanism versus an analytical framework. So we'll see how that goes. But right now, because our data sets are largely, again, in the tens of millions of rows, we like to work with sort of the data table and dplyr for some of our typical stuff. So hopefully it helped, guys. Cool. Awesome. Thanks.